Welcome to Jumbo Digital. Hall effect sensor. A Hall effect sensor is a type of transducer that is used to measure the strength and direction of a magnetic field. It is named after Edwin Hall, who discovered the phenomenon in 1879. The sensor consists of a thin strip of semiconductor material, such as silicon, with an electrical current passing through it. When a magnetic field is applied perpendicular to the current, a voltage is generated across the semiconductor strip. The magnitude of the voltage is proportional to the strength of the magnetic field. This voltage can be measured and used to determine the magnetic field strength and direction. Hall effect sensors are commonly used in a variety of applications, including speed detection, position sensing, and current sensing. They are often used in automotive applications to measure the speed and position of rotating components, such as camshafts and crankshafts. They are also used in industrial applications, such as detecting the presence of a magnetic field in a machine tool or sensing the position of a linear actuator. History of Hall effect sensor. The Hall effect was discovered in 1879 by American physicist Edwin Hall. While studying the flow of electric current in a conductor, Hall observed that when a magnetic field was applied perpendicular to the current flow, a voltage difference was created perpendicular to both the magnetic field and the current flow direction. This voltage difference became known as the Hall voltage, and the phenomenon became known as the Hall effect. The Hall effect was initially seen as a curious phenomenon with no practical applications. However, in the 1950s, researchers began to develop practical devices based on the Hall effect. The first Hall effect device was a flow meter, developed by Japanese engineer Yutaka Sakurai in 1954. The device used the Hall effect to measure the flow rate of liquids and gases. In the 1960s, Hall effect devices were used to measure magnetic fields, and the first Hall effect sensors were developed. These sensors were used in a variety of applications, including automotive ignition systems and position sensing. In the 1970s and 1980s, the development of Hall effect integrated circuits, ICs, led to the miniaturization of Hall effect sensors, making them suitable for a wider range of applications. These applications included speed sensing, current sensing, and proximity sensing. Today, Hall effect sensors are used in a wide range of applications, from automotive and industrial control systems to medical devices and consumer electronics. The development of digital signal processing (DSP) technology has also made it possible to improve the accuracy and resolution of Hall effect sensors, further expanding their range of applications. Type of Hall effect sensor. There are generally three types of Hall effect sensors. 1. Linear Hall effect sensors. These sensors are used to measure magnetic fields in a linear fashion, typically used for position sensing, such as throttle or pedal position in automotive applications. 2. Switching Hall effect sensors. These sensors are used to detect the presence or absence of a magnetic field and switch an output accordingly. They are often used in applications such as door sensors or speed sensors. 3. 3D Hall effect sensors. These sensors are capable of measuring magnetic fields in 3 dimensions, making them useful for applications that require measurement in multiple axes, such as robotics and virtual reality. In addition to these types, Hall effect sensors can also be classified as either analog or digital, depending on the output signal. Analog Hall effect sensors produce a continuous output signal that varies linearly with the strength of the magnetic field, while digital Hall effect sensors produce a digital output signal that switches on or off when a certain threshold magnetic field is detected. Working principles. The basic working principle of a Hall effect sensor is based on the Hall effect, which is the generation of a voltage difference, Hall voltage, across a conductor or semiconductor in the presence of a magnetic field. The Hall effect sensor consists of a thin strip of semiconductor material, such as silicon, with an electrical current passing through it. When a magnetic field is applied perpendicular to the current, it causes the electrons in the semiconductor to deflect, creating a voltage difference across the semiconductor strip. The magnitude of the voltage is proportional to the strength of the magnetic field. This voltage is called the Hall voltage and can be measured using electrodes placed on the semiconductor strip. The Hall effect sensor can be used to measure the strength and direction of a magnetic field. The output signal can be processed to determine the position, speed, or presence of a magnetic field. The type of output signal, analog or digital, and the sensitivity of the sensor can be adjusted using various methods such as changing the bias voltage or the geometry of the semiconductor strip. In summary, a Hall effect sensor works by detecting the Hall voltage that is generated across a semiconductor strip in the presence of a magnetic field. The magnitude of the Hall voltage is proportional to the strength of the magnetic field, and this voltage can be used to measure various physical parameters such as position, speed, and presence of the magnetic field. Hall effect current sensing in hybrid electric vehicle (HEV) applications. Hall effect current sensors are widely used in hybrid electric vehicle (HEV) applications to measure the current flowing in various components such as the battery, motor, and inverter. The Hall effect sensor measures the magnetic field generated by the current flowing through a conductor and converts it into an output voltage that is proportional to the current. In HEV applications, Hall effect current sensors are used in the following ways. 1. Battery current sensing. Hall effect sensors can be used to measure the current flowing in and out of the battery, which is a critical parameter in battery management systems. By monitoring the battery current, the battery state of charge, SOC, and state of health, SOH, can be estimated, and the battery can be protected from overcharging or overdischarging. 2. Motor current sensing. Hall effect sensors can be used to measure the current flowing in the motor windings. By measuring the motor current, the motor torque and speed can be estimated, and the motor control strategy can be optimized for maximum efficiency and performance. 3. Inverter current sensing. Hall effect sensors can be used to measure the current flowing in the inverter circuit. By measuring the inverter current, the inverter efficiency and power losses can be estimated, and the inverter control strategy can be optimized for maximum efficiency and performance. Overall, Hall effect current sensors play a crucial role in HEV applications by providing accurate and reliable measurements of the current flowing in various components. This information is used to optimize the performance and efficiency of the HEV system, and to protect the components from damage due to overcurrent or overheating. Today, Hall effect sensors are used in a wide range of applications, from automotive and industrial control systems to medical devices and consumer electronics. Video created by Jitesh Muthu. Powered by Jumbo Digital Science Technology. Thanks for watching.